Okay, now in the coming two videos, I'd like to show the both sequential computation and the parallel computation from the viewpoint of the users. So this video 4 describes the flow of sequential computation. And we pick up one example named of which model name is Conrod, and some example of the post-processing by the RiboCap prepost and the Paraview. These two are the name of the free software. And in the last slide, I'd like to mention a small thing about the logs. Okay, this slide is again shown here. So when you are going to run a sequential process of frontal star, there are three input files. The first one is the fixed name and the general control file. The second and the third one is entire mesh file and the analysis control file, respectively. Okay. So let's look at one example as shown here. Let's consider this kind of shape. It is a connecting rod. You have a very too big hole here, and the red portion shows some kind of boundary conditions are specified. For the larger hole, displacements are set to be 0. That is, they are fixed here. And at the smaller hole, UY displacement in the Y direction is specified like this. And the material constants, Young's modulus and the Poisson's ratios are also specified here. And the number of nodes and elements are like this. And the type of element is the second order tetrahedral mesh. That is a 10 node tetrahedral element. Okay. So what we are going to do is to obtain the displacement or stress distribution once you are given the stretch in these directions. Okay. So this is a typical situation when you run the frontal star on a certain Unix system. So sometimes you have your home directory and you set the subdirectory, for example, the examples and the conrod. And you also set the subdirectory named PE1. PE1 stands for the one processor. So under the in the subdirectory of PE1, what you have done is that you placed the three input files like this. HCMW control.dat, that's the general information file, and the conrod.mesh and .cont, which are mesh file and analysis control file respectively. Okay, and so the next is run the frontal star actually. So this series of commands are also example of some Unix system. Here you move to the directory where a bunch of input files are stored. And when you are going to run the frontier, actually there are various ways of activate the frontier, but in this example, you submit an script file named go frontier101.sh.shell. Okay, and inside the contents of this shell script is the execution command of the frontier, and actually the contents may differ from environment to environment, so I don't go into details, but the qsub is a very typical command when you are going to run a program on PC clusters or supercomputers. And once you submit a job which are described in this kind of shell script, then job scheduler, which is run behind you at the PC clusters or supercomputers, can control the very optimum way of your job. Okay. This is one very typical way of executing the procedure on a computational server. Okay, after finishing the finite element computation, you may get some result file, and this is just one example of the RiboCap prepost, which can also be obtained through the frontier website. It has a function of the post-processing. So if you read the computational result of the frontier, then you can describe or show the deformation of the object or distribution of stress or other physical values. And so that's why the RiboCap prepost is the reason of the name of this software. And Paraview is also a free software, and many frontier users are using Paraview as a post-processor of the frontier. And one format of the result from the frontier, Paraview can read their computational result. So and the functions of Paraview is very, very fruitful, and so you can show various deformation or distribution of physical values or more detailed visualization functions can be used for evaluating the computational results or computational stress analysis. Okay. So this is the last slide of the sequential analysis. So after finishing the finite element method or frontier computation, many type of log files are generated. This is one example through which you can see the computational time to obtain until the convergence or number of iterations required to come to the convergence. Okay. So, so far the general process information of a sequential computation of frontier star.